Hello, everyone. Uh, really nice to see so many people on Java conference interested in JavaScript and in front-end technologies in general. Also, a really wise thing was done by conference organizers with putting two kind of competing ecosystems into one time frame. So last talk was Angular, next one will be Angular, and now React, which is trying to fight some on the field with this framework and this ecosystem. And I couldn't stand stopping me from adding yet another slide to this presentation, which basically defines like the quite predictous way of how React developers could treat Angular or how they react on some presentations like previous one. So it's like, and then okay, I can just go home and everybody saw Angular 2. It's fine, it's cool. Really like their job, so they borrowed a lot from React, as React borrowed a lot from other places. It's really nice to see the competition and exciting times we're living in. So my name is Robert Haritonov. About a year ago, I moved from Riga, my hometown, to Amsterdam, and now I'm working as a front-end development lead at Liberty Global. It's a really big holding which owns a lot of telecommunication companies like Ziggo in Netherlands and Virgin in UK and many other ones. And within my team, I work on a project called Horizon Go, which is sort of European Netflix. We're building a streaming platform for our telecom customers. So basically, all the TV subscribers could view the same live content and recorded content in their browsers, in their native applications, and so on and so on. So this 4 icons represents the stack that I'm currently working on within our project. So of course, we're using React. That's why I'm here as well today. We're using Fluxible, which is one of the Flux implementation. We'll go through more details later on. We use full stack JavaScript environment. Basically, we're rendering some parts of server side, some parts of client side, and we're also trying to cover everything with full test coverage, starting from unit tests and also going through Selenium tests. So React. Raise your hands who know what React is. Okay, almost half. It's fine. I hope that most of you then will get a lot of good insights about what it actually is and what it stands for and why so many people are really hyped about it. And one more question: how many of you already used React? It's quite a lot, like 1/4. Yeah, quite unexpected, I would even say, because like Angular is longer on the market and it already had time to cover more companies that can afford switching later on to different places. So React is a JavaScript library for building UIs. I would like to emphasize that it's not a framework, it's a library, and I really mean it. So basically, we can't directly compare React with some other full-fledged frameworks like Angular or Ember, for example, because this is like only, as people usually like to name it, only a view for your kind of FMVC, even though most React projects are not following the traditional MVC and they're following Flux instead. And also this V as a view stands also for Virtual DOM, which is quite a big addition to the tooling that we have for building UIs. And it's really big in terms of switching the mindset and switching the way how we treat DOM mutation, and basically allows to declaratively define the UI code without being worried about how and when you should mutate the DOM. So basically, this library allows you to declaratively define whole UI without all the imperative approaches with touching get element by class name, putting new inner HTML, and that's it. You just don't need to worry about it at all with React. But even though it's just a library, there wouldn't be that much hype around it if it would be just a templating language or something really small that could be plugged in into anything like Angular and without being noticed much. So basically, it's everything about the ecosystem. Uh, I would say that React is like a cancer. If you add it in your project, and it's quite easy to do, to test on a few small parts of your application, and then when you start feeling benefits from it, it conquers all the rest of your code base, and suddenly at some point you don't use MVC anymore. You already are fully Flux based, and that's how it basically works. So it's not just a library. It's about everything that comes around it and about all the best practices that it promotes. So it supports server-side rendering and also cross-platform rendering, meaning that with React Native, you can, in the same way, build applications for iOS and Android, outputting the native UI, not hacky web view with quite a bunch of performance issues. Yes, Angular also supports that as well. That's basically one of the things that I personally think that Angular 2 kind of borrowed from React, but I won't go into deep comparisons since our way of presenting, comparing to previous speaker, is quite similar. So you can do your own conclusions, basically. React really brings a lot of nice patterns of functional programming into UI development, and that actually means a lot. So I will show you quite a few examples during my talk, and bringing functional paradigms into front-end development world means a lot, just because front-end developers are actually starting programming instead of writing jQuery, so it's becoming, and then it's emphasizing emphasizing the whole flow on programming, on programming the interfaces, not just throwing a bunch of divs there. Also, the component system is really powerful in React. Also show some more details about it later, so we won't stop here much. And comparing to Angular, yeah, I said that I won't compare it, but it's hard to do just because it's a really good example, especially that you heard about it like just 20 minutes ago. So comparing to Angular, it promotes one directional data flow. So everything is going from top to bottom and not from bottom to top. And this is actually makes things easier, that at least like React community says, and at least what Facebook says. But maybe Angular guys thinks other way, that two-directional binding is make things easier, but it's up to you to decide. So very, very important thing to mention is that the 0 in current version of React, which is in front of the number 14 or 15, which is the next version, doesn't mean much. So it doesn't mean that it's unstable, it's only for pet projects, etc., etc. React have been used on Facebook main page for already more than 2-3 years, actually. And this is the latest screenshot I took preparing the slides. You can see that React doesn't afraid to using even alpha version of next React release, which means that it is really stable. It's used in a lot of different production projects, really large scale projects and so on. And one interesting thing that next version will be actually not 0.15, but it will be just v15. So they dropped the 0 dot to not confuse people like somebody of you probably was before. So a bit of a history. So this quote is taken from talk of Christopher Chadao, who was presenting this idea and presenting the patterns that allow React applications to scale. He was doing this presentation on one of the JSCons, kind of like first steps into the community, where Facebook just were pushing something to front-end community and sharing some knowledge. And this is the motto that they use quite a lot on Facebook: move fast, break things, but fix them, of course, before going to prod. And basically, when Facebook started to think about some solution for fixing their problems on UI with the UI code, they focused not the problem of getting rid of a lot of bugs that could come up. They focused mostly on making things really clear and making things really easy to debug, because things will break, and if you'll make sure that you will be able to move fast, including fixing things fast, it will solve their problem. So that's where they basically went with whole those ecosystem. So Facebook achieved, thanks to React, predictable code execution environment. It's not only React, it's also other tooling around it. In most of the cases, you will hear about React in combination with Flux, maybe also with reactive programming paradigms, but the most popular combination is Flux plus React. This is also what Facebook is using, and this really helps them a lot. Also, the code written in React, it's not easy just because of declarative, and it's also easy because it is really straightforward to understand what the whole component is doing just looking at its code. So basically, if you just start playing with it, basically for you it will be like open a component code, read it from top to bottom, and that's it. You understand everything that could happen as an output from this component. So if you go from other way around, from a browser, for example, and see some bit of UI in the DOM, you will then find the component that actually represents this bit, and nobody else except this specific component could touch it. So basically, all the logic and all the state of the component is in one place, and it's really, really convenient to follow. Also, of course, we're building applications not only from one component. We have like quite a bunch of components that are put into a tree of components that could be really deep nested and so on. So React also not allows to mutate properties that were passed from the top. So if you pass some data to your tree of components, you can make sure that the component won't be mutated on the way. So you won't get any side effects on other components that might reuse the same data. Similar to TypeScript or libraries like Flow, React also supports out-of-the-box property type checking, which is quite nice things to have. And you get warning messages in console if you didn't follow it right. And also, actually, React does a lot of great, other great things for validating your code that developers don't usually configure with other tools. And it's really convenient. It really helps to easily determine the problem before pushing code to production. So it may like throw some error or throw big red warning, but it's better to see it as fast as possible rather than see it already on production, seeing that users got broken UI or something, which is really bad. And the whole thing together allows to encapsulate most of the parts and being sure that the component and its logic is tightly coupled to specific DOM place and nothing else is touched. So if you're a big company, if you have a big development team and people come and go, it's really a must-have feature that will allow people to change things without breaking the other things. Like not you fix one bug, you spawn 10 more bugs. So everything must be as much encapsulated as possible. So React makes rendering of UI as easy as calling a function or defining a function. And here's what people in the community talk about React, and which is also really surprising for me. Like talking seriously, when some newcomers come to community and ask, how do you do that? How do you do that other thing? Most of the answer is like, just write JavaScript. You know JavaScript, you're a JavaScript developer, just write JavaScript. So comparing to other ecosystems, it could be really confusing. For me, for example, when I started with working with Angular in some of the projects, it was like, okay, I need to change the class. Then what? I need to go to Angular documentation, check what Angular way of doing is for changing the class, and so on and so on. So here, the Ember example with timeout. Why not just use set timeout? Come on, it's JavaScript, you know? And this probably will be the last comparison that I will do, but yeah, probably not completely true here. But one of the things that I wanted to state out here is that there is no ideal tool for solving all the problems. And if you would ask me to say just one sentence for what Angular is good for and for what React is good for, is that Angular is really good for prototyping things, and actually when you actually have some experience and you become kind of Angular developer, how people used to call those JavaScript developers writing Angular, you could do things a lot more faster than with React. And this is true. React has a lot more bootstrap code, but this also makes code base based on React a lot more scalable and a lot more clear as well. So one thing is more about speed, and my personal opinion for projects smaller than Facebook, and something similar, of course, because probably 99% of websites are smaller than Facebook, of course. And React is about scalability. And also, React allows to drop in something really small to any application and combine it with other libraries and do whatever you like, basically. Anyway, as programmers, we need to learn tools and paradigms behind it, first of all, and tools should come later. And yeah, React just helps a bit more in this sense, in this terms, just because you write JavaScript with React, not specific hundreds of methods that you may see in some other frameworks. So why should you care about it, or at least why you should at least consider or look into React? There are actually many reasons, and I found this representation like as the biggest selling point. Of course, I'm not talking that if Facebook uses React and it's a big website that everybody should use React. Of course, it's not true. But if thousands of really good top-notch engineers are choosing for their problem-solving React, and this is, on my memory, one of the biggest examples when big companies are actually considering choosing something quite common, like a library that is used by millions of people, that is like open source and so on, over their own implementation. So people actually in those big companies behind those big titles found a lot of benefits. And we'll shortly just go through the main things that you may found in some blog posts by Netflix or some other companies that actually decided to switch at some point. So as a library, it's really easy to drop in. So you could have your data and all your business logic written in your technologies, but only UI layer, the part that outputs the rendered tree, could be done with React. As I said, one of the main features is ease of maintenance, powerful component libraries, meaning that there are a lot of components out there, and I'll show you some numbers a bit later. And isomorphic rendering, which is really cool, and it's really leveraged by Netflix, for example. They done recently a really full rewrite of their web UI, making the whole thing 10 times faster. Of course, it's not only about React, but it was one of the things that allowed them to use one of the best patterns, like showing the first view instantly rendered with all the things inside before waiting until the JavaScript will be downloaded, that will be fetched on the client, and so on and so on. And before we jump into some code examples, I would like to show you and basically cover a few things that are quite commonly mentioned with React. They could be quite scary if you didn't use none of them before, but if we will break them down into separate parts, you may already probably saw the ES6, which is basically the next version of JavaScript standard and ECMAScript standard. Babel is the tool that allows you to transform your ECMAScript 6 to normal JavaScript that runs in every browser. Probably these things were mentioned on the first talk in this room, but unfortunately it was on the other talk during the time. So these things are quite well known. They're not React bound on anything else. And these things are a bit more complex. I will show you some example to give you a bit more context so you can easier understand that. So this is an example of a simple React component with JS6 mixed in. So basically, all JavaScript, few React methods, and the only thing that may be not familiar for you is XML syntax that is mixed into component code. So basically, React pushes you writing HTML in JavaScript, which at first people were really confused about, but it really makes a lot of sense. So people talks a lot that separation of concerns is completely broken. Like you should keep your HTML in HTML file, JavaScript in JavaScript, and so on and so on. But if we really see the use cases, uh, templates are always tightly coupled with JavaScript, and it's not the right way of decoupling those things just because you will need to just jump from one file to another. So basically, this is JS6. It's almost exactly as XHTML, and it is compiled directly to functions, basically. So if you don't really like it, you can write UI in functions. So this is like the input transpiled through Babel to JS, and you can just write plain JS without being concerned about those kind of syntax trigger things. And this also allows to programmatically do some other abstractions on top of the whole ecosystem, if you like, of course. Here is the simplest example of React, and here's where I'll start describing a bit how it actually works and what's so great about it. So this is called Stateless Component, which is basically the same as just a pure function. As I mentioned before, writing UI with React is like just calling few functions and that's it. And here's a really good representation of it. So you're calling a component by component name, similar to the function name, and you pass some property, pretty much similar to the way you would do with web components and etc. And pretty much straightforward. So the properties are passed within props, and you can use the value in your HTML3 described with JSX. And everything is basically done like this. So if we'll dig into a bit more complex sort of application example, where we have few components combined into one. So basically here we have 3 components. It's like a product table, search bar, and the component that wraps them both to manage the data flow and to manage the data passing from one to another. You can see that at the start, application gets products, and then product parts are passed to other components, and you can listen to changes from like search bar, pass it down to product table again, and in this really declarative way, define how the data is flowing through your application. And as I mentioned, each of those parts are completely encapsulated, so this component should only care about the property, the immutable property, which is products array, and that's basically it. All the rest could be done completely out of the application, which also allows to test your components without tidying everything with your large code base. So you can just separately do the stuff. And another thing that you might not be familiar with is Webpack. Yeah, by the way, who knows what Webpack is? Raise your hand. Okay, not that much people, but it's totally fine because in this example, it doesn't do much. Basically, what it does, it just allows to require components like this. So this is a common JS syntax. There is a newer version of syntax for calling dependencies into a JavaScript file, which is like ES6 imports or ECMAScript 2015 imports. And this basically just allows to compile all this example to one file, resolving all the dependencies. That's the thing that Webpack does, among many other things. So, returning to the original roots of React and what was the original intent of developers behind the library. This is also one of the first talks by the same cool guy, Christopher Chidao, when he also was just started showing something to community. They were starting only with just defining that React is for building UI component libraries. So basically, like 3 years ago, it wasn't about that much things that I can tell you about during this 1-hour session. It was just about building reusable UI components. And this slide basically shows that this target and this assumption of how React should be treated works really well. So you probably know that Angular is like 5-6 years probably on the market, maybe even more or less. Yeah, I just know approximate numbers. React is widely popular only like 1.5 years ago or 2 years, so twice less in the field, let's say. And already React components have more reusable things for you to borrow from a community than Angular with twice as more history. And I didn't add it here the other comparison, like on the same ng models, if you'll search by Angular 2 tag, you will see something like 2000 vs 7, because at least those components are not marked as Angular 2. Maybe there are more, I can't say much. But this just shows that the component model works really well. And if you need to build component library, this is one of the best examples and best technologies to do that. And if you want to first see some other examples of those component libraries and play with them first before building your own thing, you can check enormous amount of projects like this ones mentioned here, like Material UI. Quite funny though that the best Material UI library for web is based on React, not Angular, because it's kind of coming from Google, the whole Material UI guidelines and so on. And these things basically allows you to also do fast prototypes on React without almost writing any new components and so on, just wrapping the other ones into like a so-called container components and pass data through one to another. And yeah, so another thing that I also would like to compare a bit, compare React with, is a really awesome project called Polymer, which is kind of a wrapper on top of the web component standard from Google. It goes really big this year. I've been also on Polymer Summit in Amsterdam this year, and I saw a lot of great ideas and things that are standing behind Polymer. React is also trying to solve this component problem and component composition problem almost the same way as guys with in Polymer are doing, but in some cases they're completely following the totally other path. So you can't use, and there's no goal of allowing you to use React components outside React. You always will need to have a React dependency to use it. But in other ways, it makes things much more simple. Because I was a great believer into web components, for example, but since many years, it's nothing much about them. Like people don't use it much, even though in many Google projects they use Polymer on production right now, and there are really great examples of ready to drop in components. And Polymer or web components could be used in many other libraries, in Angular, as we saw in previous talk, and also they could be easily dropped to React. So the same as Polymer ecosystem has a lot of integrations with different technologies and so on. React components also could be acted as wrappers on top of other technologies. Like this is an example of a library called GL React, which allows you to declaratively call WebGL-based components, which could be really powerful for animation complex or some interaction complex things that you want to bring to the web. So with this simple example, you may follow that without knowing nothing about WebGL, you can render quite powerful thing like advanced filters. And there's actually a lot more components like this, controlled exactly in the same way in the GL React repository. Same goes for React Canvas. It was followed by a really great write-up from Flipchart, or how it's called. I don't remember the exact name, unfortunately. But they at some point they decided to bring their application to web, and they wanted to keep it really close to native look and feel. You can see on this GIF, it doesn't look at web at all, and it could be really hard to do it with DOM. So basically, what they did, they create a small abstraction on top of React, because React allows to define the output not only do the output not only to the DOM, but also to like other parts with other middle layers and so on and so on. So basically, with React Canvas, you can build some similar UIs like this, just using an abstraction without imperatively defining the canvas code and defining how the canvas should be rendered in the browser. And I was mentioning a few times the thing called isomorphic rendering or universal rendering, which is like a second name of approach of rendering the same code in different environments. So in this example, I would say I would show you the flow of how the universal application is basically rendered going through its life cycle. So having the same code base, having the same components, you can configure where to render the component and in which time you would like, and in which specific time on which specific request you would like to give like a client-side render, single page application like experience, or a server-side rendered experience. So in our application, it looks like this. Whenever you first time request the application, you get everything from the server. So all the components are rendered on the server. You get the HTML with all the data inside, and followed by that a bit later, when on client side React is downloaded, it applies all the event listeners onto the DOM tree, which already came from the server side, which is really powerful and doesn't require any re-rendering of whole DOM just because React does the comparison. And basically, after first request, you proceed working with the application as with any regular single-page application. So all the page navigation will just reload specific part that developer defined, and you will get all the benefits of instant JavaScript applications. And it's really crazy easy to do this server-side rendering thing with React. So you don't need to write your own interpreters for that. You just have one simple method like render to string or render to static markup. So both of them will output a string instead of like a DOM, rendered DOM. And the only difference is that one, which is rendered to string, allows you to then rehydrate the whole application and all the events in the browser. And the second thing is for outputting statically generated websites. Like if you're building something purely server-side rendered, but you want to use some JavaScript technologies like React, it's possible. And there are quite a lot of things like Jekyll, for example, based on Ruby, reverse engineered into JavaScript using React. And one of the interesting things, since we're like on wide conference with covering many technologies, one of the best examples I recently heard how people use React was a case with .NET project where a company was forced to use .NET-based CMS just because they got clients from that field and they didn't have any other choice. But they really wanted to leverage the idea with components that React provides. And what they did, they set up the project to execute and render and to render React to HTML on the server side in like a wrapped component in the .NET. Then they pass the markup through .NET CMS, and on client side there is a React again. So React basically was like placed around .NET, and it works pretty well for them actually. It's performant and doesn't make huge difference with doing the same thing purely with Node.js, for example. So, few benefits of isomorphic rendering if you're not like yet convinced, for example. So, performance is one of the reasons. About that, you can read a really extensive article from Netflix where they showed their case studies and how they used isomorphic rendering for improving performance. And as I said, it basically allows to show the UI rendered with data and with useful information to user as fast as possible, like as fast as you can get the document request shipped into the browser without waiting for JavaScript bootstrap time and so on and so on. And also it allows to reuse a lot of parts of the code base, which is quite a powerful thing. So if like 5 years ago you would want to achieve something similar, like get benefits of server-side rendering and have benefits of single-page application rendering, you were mostly forced to duplicate your code in templates that are actually could be executed on server side and rewrite the same things on client side. Or at least you can, of course, use some templating languages that were both available on backend and frontend, but still it's not a complete experience because you lose a lot of things like event handling and so on that with React is handled by default. Good search engine optimization. Maybe a lot of you may say that, yes, Google now parses single-page applications as well, so they execute JavaScript and they run JavaScript applications with their parsing robots before they get content. But as also some other guys from like Angular conference were saying that it's not ideal yet. It's not that fast as the traditional crawling of websites, and as we know now, other search engines doesn't support that. So if you would like to be more widely covered and would like to exist in other different ecosystems and in other different search engines, you still need to have server-side rendering alternative. And with the tooling that we have, as I mentioned already, in our project we use Flexible, which out of the box supports the isomorphic rendering. You get the progressive enhancement, or you may call it like graceful degradation another way around. Really cool benefit. If your JavaScript breaks, your application still works because you always have an href as a fallback, and if JavaScript handle somehow didn't execute it, you will in the browser click on the link, and the next page will just be fully rendered on the server. So it's also quite powerful thing to have. And even though people don't turn off JavaScript in their browsers nowadays, but JavaScript could break, and sometimes it could come really unexpected. So as I said, again, React is just library, so it needs something around it to allow you writing some more or less complex application with it. So these are most popular examples, which are usually combined with React. So Flux, as I said, is like the most common one, since Facebook also uses Flux, and both Flux and React supports unidirectional data flow. So it's really a nice fit in this case. There's also a big movement from reactive community that have some bindings on ReactJS, allowing you to pass data in reactive way to React, which is not necessarily combined. Like React doesn't mean reactive actually, but one of the combinations possible like this. And there's quite a lot of materials and articles about how to combine React with Backbone, for example, since it's like V for MVC. You can use M and C from Backbone and pass data to React components as a view layer, at least for a migration phase, which is also quite powerful and useful thing to have in existing projects. Since my talk is not about Flux, I won't go to details about how it works. Basically, this chart defines the basic data flow idea, which Flux is encouraging. So basically, data is always flowing into one direction. So we have some action, which could be called with some event handler like click. Action dispatches some information to the store. So store is kind of a model, but it's combined with a controller in the real world. And then view gets all the data updates from the store. So if a UI needs to propose some changes, it doesn't do it directly to store, so it doesn't communicate directly to store. It goes through full cycle, which allows to easily then follow and debug on where the input was initiated and where it actually came out to at the end. So without any unexpected two-way binding like bugs that unexpectedly you may notice that somebody is mutating your object and you get unexpected result at the end. So this just makes the debugging process and code investigation process a lot more easier. So this is example of website and Flux implementation that we're using. There's actually quite a lot of different Flux implementations. So if you're really curious, you can Google for some Flux comparison charts. But if we'll just distill to few most biggest ones and widely adopted ones, Fluxible is one of them. Facebook Flux is also one of the top in the top rows. And I won't go also really deep into details of how Fluxible implementation works, but basically it's also could be treated as a library. So basically you have only few methods from the library that you actually need to add on top of your React application. So as I mentioned, in one-way data flow, all the handlers like onClick are calling the action with execute action. This is the part that comes from Fluxible as a library. And after the data came with the action was treated and was properly handled, the component would get from the store the update. So this is another example of the thing that Fluxible provides is a connect to stores, which is actually React component that just with the composition wraps your defined and under the hood just passes properties, immutable properties to your component. So it's easy like that. You with actions put some changes to your store and all the components are basically listening to the changes and react to them and render them in really declarative way, just following all the things that I mentioned before. Here's another project that I can't skip talking about React. It's a project called Redux. It's really trendy right now among React developers. Basically, it is a lighter alternative to Flux. It follows the same paradigms. It also follows the same single way data flow, but it allows to omit some bootstrapped code that you would need to write with Flux and make things a bit more easier. Also, later on, I will show you a few awesome tools that Redux enables you to have in your browser and which actually switches like the minimum level of comfort that developers are waiting from their development environment. Yeah, but first we'll go a bit through React Native. And as I mentioned, React could be used for building native applications for iOS and Android, which was supported quite recently. And the motto behind React Native is not write once and use everywhere. It's a bit other way around. It's learn once and write everywhere, meaning that you don't write same code that will be executed everywhere, like you could do with hybrid applications based on Cordova or Titanium or Ionic, for example, as well. Facebook pushes the idea of learning the technology stack once and using the same libraries and using the same patterns to develop different applications. But this also doesn't mean that you can't reuse actually the code from application to another. There's a really nice write-up from Facebook where they shared their experience building a cross-platform application which has a native UI both for iOS and Android, not just a web view with rendered client-side technologies in it. And in their use case, they described how they went through the whole thing and how they managed to have single repository for both applications and how they managed to reuse around 80-90% of code. It's not full code reuse because it's nearly impossible because of the platform differences, but 80% code reuse, it's a lot. And you may imagine that these resources cost a lot, and if you could cut them in half and cut the development speed of next application, next platform in half and even more, you benefit a lot from that. So here's a short example of how you switch from React for web to React for native. Basically, you write exactly the same code. You write JavaScript, which is executed within the native application in separate thread, which doesn't block the main UI layer. And as we saw with React GL or GL React and React Canvas, you have this simple abstraction. So basically, this component represents the native component available on iOS. The same comes from all the other things. And if you don't find some specific component binding, uh, you may ask your iOS platform developer to add another one, which is not that big hassle to do actually. And apart from markup, of course, you need to define some styles. And here's the solution from React that allows to have really CSS-like syntax for defining the style of native UI. They use Flexbox for defining the whole the main UI, and all the other parts are quite similar to CSS, although they don't always follow the same standard. The same approach is actually available also in React for web. Like you can write CSS in JavaScript for the web, and it's quite useful, especially for component libraries, because they allow to easily call component from a library without this hassle of solving some conflicts with Bootstrap that you already had in your project, with other CSS styles, and so on and so on. And basically, this also means that you may have not only the business logic and UI shared from web to native, but also some styles could be reused like this as well. Or at least developer who does the full cross-platform development will not be lost, and he will understand just because he knows what it is and he knows CSS. And this is quite similar. That's not that doesn't have really much differences from CSS for the web. So yeah, benefits are quite obvious. Native UI means native experience. You can execute JavaScript in a separate thread, so your heavy JavaScript business logic tasks won't block the UI, and user won't feel any like chunks and FPS drawbacks. And also, yeah, it reuses allows the reuse a lot of code base, and which is really important and which is not currently available as far as I know, at least with current native technologies. It allows to ship instant releases, meaning that you don't need to follow the whole life cycle of Apple review or Google Store review, which is a bit faster, but still you have some review and some people in the process that are standing in front of you before you can push something to your users. And there are a lot of services already that allows to push updates to React native based application instantly. So the same way as you do in the web, without any reviews, without anybody from Apple or Google standing in your way. So if you have a bug, you don't need to wait for a week until a user will update the app and he will get the fix for it. You just ship another thing and you're done. The same goes with A/B testing and other important things you need to follow during the software development. And also, this thing plus many other benefits makes the development experience better a lot. And developer experience is now a really big thing. Many people mention it a lot, and this really matters. This really works. And some native developers, like iOS developers, already are switching to React Native just because of some interesting tools and the benefits that platform provides. So since we have only 1 minute, I'll go really fast through my bonus section of the slides. So one of the greatest things you will get using React Native is live reload for a native application. So this is the thing that probably all the native developers were dreaming about. You just do code changes in your editor of your choice. You click save, and after a second, you get the rendered state in your application. And it's not refreshing. It also allows you to hold the state. So if you had some data there or you navigated already to some page, code change will keep the state of the application. It will just change the output. Another cool project that allows to showcase React Native applications in the web, which is also not quite common within native development ecosystem. This also allows to demo the components that you may reuse in the web, so people could play with it before putting into to the code and running the application. So returning to Redux, the greatest thing that it allows to do with its single store and the way how they treat things is tools like time travel, so-called time travel, that allows you to or reproduce the whole state of the application. So if you see here like a to-do application, uh, after doing some steps in the development tools, you could just remove one of the steps. Like if you added 10 to-dos, you can remove the second added to-do, or you can revert the check action that was done. So this is really powerful when it comes to development and debugging. And yeah, similar with live development for the web and live reload. This is an example of style guide that is lively coupled with the code that you're writing in your editor, which also highly affects the developer experience at the end. Just a few more links that you will be able to click when you'll get the presentation from Twitter and from other places that from my Twitter account and official Twitter account of Riga that they will share. So these are few most important places that will help you starting with React. And the best place is still the React main project page. They have really great tutorials, and you could jump in really fast. Like literally, you just need like half an hour, and you will be able to write decent React applications. And that's it. Thank you for your attention. I think we still have like 7 minutes for questions, or if not, we can do it right after the session during the break. Just catch me till the end of the day. I will be here around tomorrow workshops as well. So questions?
So I've heard that heavily form-based applications are difficult, like kind of enterprise type workflow-driven form applications.
Yeah, that's true. Forms are the weak point of React because in the forms are the place where you actually greatly benefit from two-way data binding. There's not that much of similar use cases like forms on the web and regular UI development tasks. But yeah, talking honestly, forms are not the best way. But React provides extensions that allows to do something like two-way data binding for forms. So it's solvable, but not ideal for forms. Any other questions? Yeah, here's one.
In terms of React Native, what is the overhead if comparing to native apps in terms of size and speed?
So of course, React Native is not that mature as native platforms at this point of time, even though it's the most rapidly developing project right now in React ecosystem. So they release a lot, and Facebook puts a lot of efforts into building the library. But still, of course, you may experience some bugs, lack of some integrations with native elements, and maybe at some really business logic extensive tasks that need to be executed on the device itself. It may lack some performance just because JavaScript is executed during the app runtime. It's not built. It's executed in another thread. So these are basically potential drawbacks. So you may experience some bugs just because it's still quite new. And in really intensive applications, you will probably face some performance problems. But it's not about regular UI-driven applications. Of course, you won't write a game in React Native, for example, but if you need to build something like Instagram, it's up to you, and most likely you won't have any performance downsides just because the UI is quite simple and the logic for rendering the UI is quite simple.
One more question. Are there any possibilities to use classic CSS preprocessors like LESS or SAS with such with such styles in JavaScript approach?
You mean in case with CSS and JavaScript, right?
Yeah.
Yeah, because without CSS and JavaScript, you can do whatever you want, of course.
Yeah.
But with CSS and JavaScript, there are actually quite a lot of libraries that allows you to do this crazy thing like writing CSS and JavaScript. And since CSS and JavaScript is just an object, it's really easy to precompile and mutate the result before it gets to the browser. So this is basically what preprocessors also does. And there's already, if you know a project called like autoprefixer, there is an autoprefixer for CSS and JS. And all the rest is mostly handled by JavaScript, because you don't need less in CSS and JS because you have JavaScript there.
Yeah.
Less is like a hack to replace JavaScript, basically, in case of style handling.
Thank you.
All right, so I don't see any more questions. So as I said, just catch me after the talk if you have something to discuss, Holy War, and so on. I'm here for any types of discussions. Thank you.